Boom. Chris, I think we're on air.
Hi, good afternoon, Max.
Hi. Hey, I have a new microphone. Is the audio quality now better?
It sounds pretty sharp to me. I can hear you loud and clear.
Nice. My voice is sharper than my brain. I like it. Okay, so I guess the topic that we want to discuss today is data exchange, right?
Yes.
In the aviation industry. And honestly, I was awestruck because, I was working at Shippo, we did supply chain optimization. And for me, it was very clear that every retailer has a very strong supply chain management like software or mechanism in their organizations, manufacturers as well. And I thought, okay, well, for the aviation industry, that's a no-brainer, right? Because the assets are so expensive, there's so many people, so many goods on there. It's a no-brainer. What is your take on this?
So, unfortunately, or maybe luckily, we're in a really traditional industry, right? So, the technology we use to communicate with aircraft is World War I technology, and the technology we use to locate aircraft is World War II technology, being VHF radio and radar. And not too long ago, when airlines and airports talked about flights, they talked in a totally different vocabulary. So one airline would say, my flight arrives at 10. Another airline said, my flight arrives at 11. And one actually meant, the time that it's on the stand. The other one actually meant that, it was when it touched down on the runway. Mm-hmm. So it was just, just imagine people from different countries speaking different languages trying to run an operation.
And interesting. So it's the problem has a lot of levels. It's how they communicate, and they're not even talking the same language in terms of what they want to communicate.
Exactly. And again, if you look back at in history, when there was, small airports, few flights, couple of flights a day, guys with binoculars overseeing everything, it's all pretty straightforward. And then, you get away with it. But as the demand for air travel has increased and the pressure on the system has increased, you just don't get away with it anymore.
Yeah, and I think this is a nice demonstration in this video, right? Talking about pressure. Boy, it's actually fascinating that the industry works without having, unified data exchange format. Pretty sick, actually. Okay, I'm gonna quickly switch screens. Boom. Bam. So yes,
and I think
sorry.
Maybe not to totally sell the industry short. Like there has been great advancements, obviously, to address this topic, right? So it's not that we're literally in the dark ages, because ACDM, which is airport collaborative decision making, has been a very successful initiative trying to address this and making sure that in a very basic matter we align definitions across the industry, at least in Europe.
Yeah.
And incentivizing airports and airlines to share certain information point with each other.
Yeah, but
there's a good first step.
Okay, but how established is like this, data exchange? Because I imagine if you do a flight from, let's say, Munich to Paris, right? Then in my world, all the data that's generated about the flight in Munich, actually Paris airport will get in real time, right? So that they can adjust schedules accordingly, and so on and so forth. Like, is data exchange happening to this level in ACDM, or is this more like, okay, we're gonna, define 16 data fields and what we're gonna put into each data fields?
So it is happening to a certain extent, only for airports that participate in this ACDM endeavor.
Okay.
So many of the large airports in Europe sort of have to, and they will share certain milestones around a flight.
Yeah.
With each other, which is, for example, the flight has actually taken off. And this is for passenger flights. For cargo, again, it's different. And as a result of that, there is examples where that I know of, that there's ground crews waiting for an aircraft full of flowers from Kenya, and they are standing on the stand, but the aircraft, I don't know, 16 hours ago, or less than 16 hours ago, but like 10 hours ago, never even left Kenya, but they just don't know about it.
Yeah. So what I meant is, valuable information that Paris in this example could use to derive insights, right? For example, was the plane fueled in Munich? Because Paris airports could play that information into, their optimization layer, be it AI or more traditional algorithm-powered software. And maybe the gate allocation would allocate another gate and would make the overall process more efficient if Paris' system just knew that the plane doesn't need to be fueled, most likely.
Yeah, no, true. I think the major shortcomings are the level of granularity.
Okay.
And so there's just these few milestones.
Yeah.
That's one. And the second major issue, I think, is the quality of the data points, where
Okay.
some, because they're already automated, actually quite high in quality,
Uh-huh.
but some, because they're totally dependent on manual inputs, are very low in quality. And obviously garbage in this case is also garbage out.
Yeah, makes sense. Okay. Maybe let's switch to the presentation we're seeing in front of us, right? And we were very, very honored and grateful to have Massimo Ciccetti from IATA on our webinar yesterday. And he shared this awesome presentation with the world yesterday on our webinar. And essentially, I think you can divide the slide into two subsections, if you will, right? So we have robotics, employees, vehicles, tracking and mobility, AI, and data standard format. Well, what are your thoughts? How do these elements interact with each other?
So for me, like robotics obviously speaks to the mind because it's, things moving on its own. But for me, robotics is actually just a mechanical part.
Mm-hmm.
And in order to make any robot act in a meaningful way, you actually need some sort of intelligence, being artificial intelligence.
Mm-hmm.
And you can only get a quality artificial intelligence with quality data. Mm-hmm. Because an AI will need to be trained on live situations and on data from live situations. So I think in a sense, there's the robotics, which is the execution, there's the AI, that's the brain, and then there's the data that can come from employees, vehicles, tracking, mobility, in order to feed that AI, to feed that brain. And obviously the data standard format is very crucial here, because if you have different definitions and different data standards and different data formats everywhere, then you're also gonna get, a brain that's gonna get very confused, to keep it simple.
Mm-hmm. So can we say that, robotics and employees and so on, this is kind of the executive layer that's, however, also generating some amount of data, right? Because if you have, autonomous pushback tugs, they will give you a much better information about the status than, the manual ones, because yeah. And then you have the brain in terms, this could be, AI or something. If we talk about AI in the sense of coordination layer, right? Not necessarily perception, but coordination.
Yeah.
So how does the data standard format that actually Massimo is working on, right? And we're working on as well in the IATA working group. How does this play into AI and the other stuff?
So I think it's probably bi-directional. So first, if you want to train an AI that's going to do optimization, mm-hmm. The inputs will need to be aligned, ideally. And if you have data coming from different areas, you'll need to know that, how do I make sense of this data? What does it actually mean? And the more synchronized and standardized it is from the beginning, the more easier it is to get results quickly and mm-hmm. quality results. So if we take one step back to the ACDM example, ACDM is basically a patch to fix something that was grown into a situation that wasn't sustainable anymore. And I guess what we're trying to do together with IATA is, if we talk about a more granular data and optimization for the ramp from the get-go to make sure that we get those definitions and data standards synchronized and standardized, so we don't have to fix it later on.
Right. So that's like the training aspect for AI.
Yeah.
Okay.
And I think on the other side, that's why I said bi-directional.
Yeah.
On the output level, so if the brain is going to give suggestions, recommendations, or tasks to robots, basically, or whatever, then also again it needs to be ideally in the same, communicated in the same way, in the same data format, with the same definitions. Especially if you consider that an airline is a company that works with different airports at different locations. If there's going to be outputs from AIs at different airports, and they're all going to be different in terms of data formats and definitions, then just imagine the amount of work that this one airline would have to do on their side in order to interpret all of that. And that's I guess a major roadblock in terms of road to success and time to market for these kind of solutions.
So the mere fact that it's multi-layered, it's on an airport level. First of all, right, that's kind of the microcosm from an airline's point of view, because that's just one of the bases that I fly to. And then it's also on a network level, because you actually want to understand what is the performance of all those individual bases, right? And ideally want them to communicate with each other. But also I think the number of different stakeholders, right? You then have traffic control, all the parties that are involved in the turnaround, and so on and so forth. Yeah, that makes sense. So that's actually pretty hard, pretty difficult problem. It feels and felt very easy from the outside, but it's actually really hard to get this off the ground. So what do you think is the timeline towards this new data standard format, and then the means to actually exchange this data properly?
That's a good question. I think a major advantage is that we're trying to do it at the beginning, because if you look at ACDM again, the exercise is actually super simple, as long as you have agreement. But it's almost the same as sit down with every country in the world and let's go to one language. Would be better, would be easier. Everyone will agree. Okay, next step. Which language are we going to use? Well, there we're going to find some different opinions, I guess. The good thing is, to keep the analogy going, I think we're in a situation where there's not too many different languages and different people talking in different languages.
Okay.
So I think it will be much easier to now say, hey, we're going to start talking. What language are we going to talk?
Yeah, that makes sense. Okay, so that can be an enabler, actually, that we're pretty early in the life cycle of digitalization.
Yeah, I'm trying to escape answering this question directly.
I can feel that.
Coming up with the time frame.
Okay, cool. I think that was a good high-level introduction, and I think we now understand why it's so important to have a standardized data format, and also what the challenges are, right? So we appreciate the task much better than we did originally. Shall we take a few moments and look into what is actually the potential that can be realized from that? And Massimo, I have to clean my annotations here from the screen. Clear all drawings, boom. And Massimo shared some, right? So we're talking about improving ground ops efficiency, which is divided into delays that we can reduce, and other stuff that we'll see in the next couple of slides. So I guess here the play would be that you look at, okay, the delays that are being accrued per turnaround, and because, for example, the fueler, the caterer, and the turnaround coordinator are speaking the same language, they could interact better, and maybe in an automated fashion, where you have a system in the background that is actually pushing notifications and alerts to different people. Is that kind of the vision that's behind this slide, you think?
Yeah, I think there's the way I understood it is there's an assumption on how much efficiency can be gained if all this technology actually is rolled out and implemented, and it has different levels or different areas in which it creates benefits. And this one really relates to, if we make it more efficient because of all that automation, how much less delay do we have? And then what's the cost of a delay?
Mm-hmm.
And then we can actually see that the gains are quite significant.
Yeah. The second thing, ground damage. And my initial reaction was, how do you profit from a standardized data format with regards to ground damage? And then I actually then I thought a little bit, and I actually see two avenues that just came to my mind, right? One is if you want to have autonomous ramp operations, that's going back to robotics, then you need a standardized data format, right? Because if you tell, I don't know, the pushback tug, the autonomous pushback tug, the wrong aircraft type, that's going to be a huge problem.
Yeah.
And the second thing, I guess, is data collection. So what we did at Osaya is we're watching the speed, we're monitoring the speed of pushback operations. So if you can correlate that speed with a specific tail, and then understand if the speed has been exceeded multiple times, how does it correlate with the maintenance cost for example, the front gear? Then I think that would also be an area where the industry could benefit enormously from a standardized data format.
Yeah, and again, it's the most simple example. Are we measuring speed in kilometers or in miles?
Yeah,
it makes a big difference.
Yeah, true.
And it's important obviously for the airports, the airlines, but also there's going to be different suppliers,
right,
that kind of supply different components. And if each one of them is going to have if some of them are going to measure stuff and deliver stuff based on miles and some in kilometers per hour, then it's going to get messy for sure.
Yeah, definitely. Okay, reducing turnaround costs. So that's related to the actual, work at the aircraft, right?
Yeah. I think this is literally sort of the cost of owning the equipment and the people needing to operate the equipment.
Okay.
To do all the ground handling activities for a turnaround. Yeah.
That makes sense. And there might be some potential in there with, electric tugs versus diesel powered tugs and so on and so forth.
Yeah, and autonomous ones as well. Yeah.
Yeah, exactly. Going back, and for that you also need a standardized data format.
Yes.
And I think this is more like the bottom line, right? So if you adopt all these new technologies, to which we said belongs robotics, data exchange, data format, and AI, then this is one of the results that you actually can achieve, right?
Yeah.
Cool. And the other one is obviously safety, as we already talked about, pushback speed. I guess what will be interesting is how do you actually include the human in this entire process, right? So for example, if you have, a marshaller that's not paying attention and allows the pilot to oversteer or understeer, what is the feedback loop against that? Like you have to put. I think that will remain a challenge for some time.
Yeah.
Okay. Do you have any other thoughts, Chris?
No, I think it's interesting to see that automation, optimization, reduction of delay minutes, increasing on-time performance, obviously, as we've seen on the slides, has huge amounts of money that we can make for the industry. But safety actually, is topping that list.
Yeah, it's
unbelievable. Look at 2030, it's 1.2 billion if I read it correctly here.
Yeah.
That's significant amount of money, and that's just the money, right? Just think about all the stress and the harm and potentially the loss of lives of people.
Yeah, you can see here there's 12 people are dying per year in ramp operations, right?
Yeah. Didn't we hear from someone in the industry that working on the ramp as ground handling is actually one of the most dangerous professions in the world?
Yeah, I think it's only topped by a coal miner or something like that. That's what the person said.
Crazy.
Yeah, it's really crazy. It's unbelievable. And so much can be done with comparatively little investment not to fix this.
Yeah.
Cool. All right, Chris, I would say let's call it a day.
Yeah.
Thank
Nice.
you. Thank you so much.
Thank you. Thank you too, Max. See you next time.
See you. Bye-bye.